And we made it. Does the camera catch us? Yes, it does.
Awesome. Welcome to another episode of Labs Talk.
Yes, welcome everybody. We're here in a different room, different setup this time because our GoPro again left us behind, I believe. So we're not good friends with our GoPro drivers on Mac.
We're good in improvising.
But we made it. Yeah.
We made it. We're here.
Exactly.
We have a proper video conference set up, and we're recording this with a video room.
Yes, and we are, of course, again, live from Garching, close by Munich, from SAP Labs Munich. And we have an exciting topic today. I'm really looking forward to that. And we have so many videos and cool stuff that we can show you today. That's going to be amazing, really.
It's actually the third part in a series. It's not a new topic for those that watch frequently.
First part was
spoke with Alona from Devantro.
Exactly. Second part was Kuka. That was the last part, right? With Lisbeth.
We spoke about AI and knowledge management in industrial robotics.
Perfect. And today we have Rene from Reply that we're going to announce and also intro to you in a second. And we're going to have the coolest robots on Earth actually today. So embodied AI. Exciting. So that really means robots in a human form factor coming very close to us human beings, I believe. So
all right. With that, let's
bring
Rene
on if I find you in these many elements that I can add. Hi, Rene.
Welcome, Rene.
How are you?
I'm doing fine. Thanks for having me. Unfortunately, I cannot be with you in person today, but hey, we are living in modern times, so we can still have a chat.
Yeah,
indeed. Rene, we'll find an opportunity, but for the time being, we're virtual, and we're happy to have you, Rene. Tell us a little bit about yourself. We got in touch over this topic of robotics. You work with a close partner of ours, and you have a lot that you can share with us. But let's maybe start to introduce yourself.
Yes. So my name is Rene. I work for a company called Reply, which is a consulting company with around 15,000 employees worldwide. And we're also a strong partner with SAP. Basically, what we do is consulting and system integration for various topics. What I do in the company is I work for our CTO, and I manage what we call communities of practices, which are, if you will, innovative teams that work on specific topics. So I look after teams that work on digital humans, which we're going to cover today. Also spatial computing, quantum and future of computing, general AI, and synthetic data. These are the kind of my topics that I do. I'm also quite an active speaker at conferences, so you might find me speaking at various events about, deep tech stuff on the topics I just mentioned. And I'm also doing my own podcast, Digital Dialogues, if you want to tune in as well. So
we're going to link to that. Thanks for mentioning.
Absolutely. Yes. So I think to start with, right, you mentioned the topic already. We wanted to talk about embodied AI today. That's our specific topic. And just to get started, it really means, and that's what I still remember from our pre-chat, it really means robotics in a human form factor, right? And I think we wanted to take a look at a couple of these robots. So I'm going to share my screen in a second or so. But what else would you like to add when we're talking about embodied AI?
So what we have these days is some pretty advanced artificial intelligence models. Actually, I don't like the term AI or artificial intelligence too much. I rather prefer the term machine intelligence, because what is artificial in the end anyway, right? And so we're giving intelligence to machines. And mainly what we're seeing these days, thanks to generative AI, is a big boom, but mostly it's basically text-based system, chat-based systems. And embodiment basically means you give an AI a body in the end. And that could be multiple different things. One you mentioned already is, for example, a robot in a humanoid form factor, for example, where this is an embodiment of an AI system. Or it could also be a digital human, where you're basically replicating a human as a 3D model or an AI-generated 2D avatar that you would see on a screen.
Mm-hmm. So let's I would say let's look at some of these robots here. So we have the Boston Dynamics Atlas I just learned, right? So there's a new version, and that is apparently the new version with this how did you call that?
It
Dyson
like
vacuum on top.
This air fan from another.
Wow. And this looks
company.
I think it also goes as a selfie cam, with the light ring kind of a thing.
Right. That's true.
Maybe that's the whole purpose. Hey, Atlas, come to me, take a photo, or be my streamer or something.
I just
It's a
wanted to
big
ask
thing for
you,
humans, after all, right?
what is
Lots
the-
of the internet is full of those guys that want to
Yeah.
take pictures.
but what is a typical use case for such a robot, for example?
Yeah.
So is this robot meant to help me cooking or kill someone or do something in an industrial setting? What is the
Well, the main purpose of these humanoid robots, and we can also split them into two different categories for humanoid robots. And
Mhm.
the one you're showing here, the Boston Dynamics Atlas, goes into a category which we call task-based robotics. In comparison, if you're later on talk about Ameca, you have on the right-hand side there with the more, I would say, humanoid realistic face and very strong facial impressions with 32 servo motors. These robots are more based for interaction-based systems, right?
Mhm.
So if we go back to the Atlas, and there's also other ones like the Amazon Digit, the Unitree H1, and all of those robots, you see, they don't look very much like a human face. And that's not the purpose so much, but they are in a human shape. They are bipedal, so they have two legs like we walk as humans, right? And the task for them is, you see it already there with the Unitree H1 carrying kind of a heavy load, right? For them, the task is really to execute tasks, to work in a factory. For example, the Boston Dynamics Atlas on top there, they just recently showed from Boston Dynamics a nice new demo video where Atlas is actually inside of a factory and picks up material. So it's a kind of a car factory, and the robot, grabs an item from like a bin and then takes it out and puts it into another shelf, right? And does this for many, many things, repetitive tasks. And this is where we will see these task-based humanoid robots being used in these kind of industrial settings, manufacturing, automotive scenarios. Because in the end, our world around us and the whole also factories, they're built by humans for humans. And although we see also these kind of robots that are on wheels and moving pallets around in a warehouse and these kind of things, you also see the Amazon Digit there on the left, bottom left, right? That is actually also holding a bin and so on. So even Amazon, with their warehouse setting, where they already have these robots on wheels that move pallets around, are also investing in a humanoid form factor, because they also realize, well, for tasks like picking and where you really have a humanoid form factor, these humanoid robots are more important and fulfill lots of tasks. And so to make it short, they are not built to look like humans in a sense of from the visual aspect, but to do work like humans.
It makes sense to me. And I just wondered actually if that could be a phase, right? So it could be that nowadays, when we still have lots of humans in these factories, then of course the robots that assist you need to look human-like or need to behave human-like, because we still have humans working there. Once the robots took over, then there's no more need to make the factory.
Let's not jump into the future for too much, and
Well,
let's stick to that, to use cases for those robots and other robots for a second, Rene. When we prepared for this episode, we understand you and the company Reply you're working for, you do actually implement use cases for your customers using robots, and you do showcase use cases. Can we talk about that for a little bit? What is it that you use robots in your work?
Yes. It's a good question. And the whole humanoid robotics aspect is really just at the beginning right now. We see this year the first time pretty much an explosion. The robots we just looked at are the first ones available. In fact, the only one you can buy is the Unitree H1 commercially. We also acquired that. Actually, for you guys in Munich, it's actually just a few kilometers away from you, because we have it in our Munich office actually.
Okay,
so
right.
we can arrange some time that you visit Unitree H1. So what we're building with that one. So for the humanoid robots, we're researching how we can actually implement it with our clients to, do these kind of tests that I mentioned. So we have also lots of clients in the automotive industry, in manufacturing. And for these kind of scenarios, we're thinking also about bringing in these humanoid robots. What we are building is the perception system, the software stack, the whole AI that runs these robots. Because in the end, what you have is a machine with lots of motors, right? But and then you have a remote control usually to control them and to move them around, right? They don't work autonomously. So what we do is to bring in these autonomous tasks into these robotic systems. Another one from Boston Dynamics, which we're working with since many years now, we were actually the first company in Europe to have 2 of the Boston Dynamics Spot robots. These are the quadruple robots, the robo dog, right? It looks like a dog.
Right, but that's not
right.
The non-human robot, right?
Non-human form factor, and this is like we're working with that since 4 or 5 years or something like this, or maybe 3-4 years. I don't recall exactly, but many years now. And this is also a lot of interesting cases we developed with these robotic systems. So one, for example, is we're also working with a company that is basically Hamburg Port Authority. Well, it's not a company, but it's a kind of the Hamburg Port Authority in the end. And so you also have to maintain bridges in the Hamburg port, and also very long bridges, like a few kilometer long bridges. And you can imagine a very important topic for me, especially because I'm in Dresden, right? Like you might have heard about the bridge collapse that happened.
I remember that. Yeah.
Months ago now. And by the way, if I go back to the city and I look at it, there's still lots of debris in the river. It's unbelievable. It's like 8 weeks now. But anyhow, bridge inspection is a very important topic, as we all have learned. And so Hamburg Port Authority was very smart. They actually worked with us since a few years now. And what we did for them is we created a solution where we can mount a laser scanner, or so-called LiDAR scanner, on the back of the robot, on the robot dog, right? And then the robot goes inside of the bridge and uses this high-resolution laser scanner to make a super high-resolution 3D scan of the interior. And then a human bridge inspector can basically check it out on their desk, right?
Perfect.
Of course,
we have a video of Spot available. Let's actually play the video and talk to it while we play it, okay? So then we all have a what to talk about, right? I can turn this down, actually. All right, perfect. So is this what you're actually talking about? Is this the use case, or is it something?
That is the Boston Dynamics Spot robot, and another robot we want to use is called Jackal. And what you see here is a different topic, but it's even more impressive. So what we're doing here is a so-called multi-agent system. So think about each robot is its own agent in the system, and then we have a so-called orchestrator that basically orchestrates these robots to fulfill a task. And you as a human can simply use a natural language interface. You can simply tell the robot, you might have seen it at the beginning of the video, the instructor, the human, said, bring me something healthy. And then this fleet of robots, the orchestrator basically knows the skills of these various robots, right? One has an arm, can open the door. Okay, so this guy goes, open the door. Another robot picks the apple, and the other one has the shelf, right, to carry it. So, so the orchestrator picks the right robots, sends them to do the task, to do the action, the navigation, and also manipulation, and then do this fully end-to-end. Because like I said, the robot, these Boston Dynamics Spots, are usually controlled with a remote control, right?
Okay.
But we make them autonomous to fulfill these tasks. Perfect. And also with multi-agent systems, right?
Only one thing, like just looking at that video that we had here for a second, and you explaining how they're supposed to interact with humans, they don't look
human,
very trustworthy. Like it's very clearly.
That's why I think that's why we should now actually. I think just in terms of the talk track also and what we prepared, right? So let's get back to our SAP use case, even, right?
Yeah.
That's something we prepared with Amica, which is one of these human-like looking robots, right? And maybe we can play that video and discuss a bit how we actually know how embodied AI comes together here, basically. Yes. So let me try to find the video. This is it.
But it's a good point. So what you see here is a demo we had at the DSAG Congress.
I'm functioning at full capacity, ready to assist you with any SAP-related inquiries or case creations. How can I help you today?
So here you can hear Amica. Maybe we can just mute the video.
My Amazon.
Here we go.
Right. So what you see here is a use case we're presenting with one of these humanoid robots. But in this case, again, not a task-based robot, but a purely interaction-based robot. I mean, this robot is a bust, right? It doesn't have arms, it doesn't have legs. So it's simply for human-machine interaction in the end. And what we have shown here at the DSAG Congress, which is the biggest German-speaking SAP user congress, by the way, they had 6,000 attendees or so. And so what we showed here is an integration with the SAP Service Cloud. And what I'm demonstrating here in the video is basically like this. So you see on the left there is the Amazon Echo, like all of us might know this device, right? And that was the fun play, because like, you know, what we have there with Amica is basically the next iteration of that, if you will, right? And the idea was this Echo device is broken and the user has to fix it. And what the user is going to do is he's simply going to ask the robot, Amica, please help me to fix this Amazon Echo thing. And then Amica will basically give you a simple instruction, or depends really, because we have a smart AI behind it, what it basically will provide you initially suggestions. And then usually it won't help to fix the problem. And then you can basically create a ticket in the SAP Service Cloud, which you see here, right? You can create a case. And that case, and you see that the German interface here, Fälle in German, is then created automatically in the SAP Service Cloud. Also, the gist of the issue was extracted from the natural conversation. And then an expert, a true expert, can actually put in some notes, can put in full instructions, which are then sent back to Amica, or basically Amica actually fetches the SAP Service Cloud API to get the repair instructions in the end that the human expert provided, and then she can help you with
That's
these
so
kind
cool.
of things.
That's a much more friendly appearance towards a human partner.
I love it
these
really. So
four-legged dogs are totally.
So
cool.
what we have here in the end is basically a user interface, just a different user interface, a more empathetic human user interface. And there's many other use cases, obviously, but that's an interesting fact. And I can tell you, having shown this at this expo and other events, like when you see it with your own eyes, Amica is really impressive. Although it doesn't look very humanoid with the skin color and the head and so on. If she looks you in the eyes and then even follows and tracks you, it really feels immersive. Some people might say it's always a little bit creepy, but it's very much immersive, and it gives us a hint of where we're going at.
When you talk about other use cases, like we saw that video and that you talk to this, say, service agent, that's one use case, but you said there's other use cases. What else is it that you can use these facial expression robot for?
Yeah, so on this part with Amica, we're also working on a project for advanced driver distraction warning systems, which is short ADDWS. And that's a thing that automotive companies have to implement as part of regulation that is coming from the EU, I think until 2026 or something. So basically every car needs to be equipped with sensors that will track you when you drive, that you don't fall asleep, that you're not distracted, and that you're really focused, kind of a thing, right? And so these systems need to be tested. And I know from some sensor companies and automotive manufacturers that are testing these systems right now, but with humans. So they set humans in the car and test them. What we did is we used Amica, because Amica has a very good, realistic human face, can do a lot of mimics with her 32 servo motors in the face, but also the eyes are very good. They're very realistic, and they also have this little reflection point, right? When you put it like a light, like you can see here in my glasses, there's this white reflection point. That is actually being used by eye tracking systems, and they are also implemented in these cars to see if someone feels distracted and so on, because your eyes will shut and these kind of a thing. And so we can simulate all of this with Amica. And you see also with the gentleman, we can record all these mimics or actually apply them in real time. So what we did here, the gentleman is basically recording all of these different facial expressions, and we can also simulate a lot of those with synthetic data on top. And then we can just play them and run these simulations for hours.
That is super stunning, right?
It's fun to look at, but just Rene, just to get that straight. So the use case that you're describing, that's really about testing that driver distraction system. So it's not about that robot in first place, but testing that driver distraction system.
Testing the driver distraction system by using the robot as a dummy, if you will.
Okay.
Right.
Okay. Got it.
And the robot is so realistic, especially the eyes, that we can actually, say, okay, it's like a human. And the skin color and all of these things don't matter anyway, because it's using RGB and infrared cameras and what have you.
Got it.
So it works really well.
But getting back to the human interaction, where this is about driver distraction, this is not so much the interaction, but observation. I'm pretty sure you have one more case that's really about interaction with humans.
Yeah, and like I said, when we talk about embodied AI, when we talked about robots, right? We have the task-based robotic systems like that can walk, carry stuff around, and then we have the more interaction-based systems like Ameca, which are really meant for human-machine interaction and having a more empathetic interface. And the other form of that is a digital human. So basically, you have a 3D rendering or an AI-generated avatar that is a kind of, think about Ameca, but on a screen kind of a thing, right? But with realistic look and feel, also with our effective computing. And here you can see that actually in action deployed one of our digital humans that we created for a client. The client is Costa Cruises or Carnival Cruises in the US. It's basically a cruise ship company that mainly operates in the Mediterranean Sea. And here is a deployment that we made with a digital human. She's called Futura. And Futura is your assistant to give you information about, excursions, or you can actually book an excursion like a trip to whatever, Madrid or whatever the ship will stop at. Madrid, Barcelona, of course, and where the ship will stop, and you can basically get more information, and you can even book an excursion with it. And the cool part about it is it also has an affective computing component. So let me unpack that for a second. Affective computing basically means not effective, but affective. It basically goes in the direction of having a more empathetic user interface. So we can understand the sentiment of the user by multiple signals. For example, we can analyze what the user is saying, but also how they are saying it, to tonality. And that already gives us a little bit of hint how they're feeling right now, what that kind of sentiment is. And for example, if you're feeling down, or if you're had a bad day, and the system finds out that you're not doing so well today, then the system will react accordingly. So more empathetic, trying to cheer you up, and these kind of things. And in this particular case with Futura deployed on the ship, it's mainly also a big factor that basically the ticket counter, where I of course have a human sitting, is already too full, right? Always long lines. And now people can actually go to the kiosk with the digital human and can do similar things there. And it's much more used than the mobile app, because they could also just book it via the mobile app, but people actually want to talk with a human. And that's what we see there. We have a 10 times higher interaction rate with the digital human.
Okay, that's impressive.
Reminds me of these Deutsche Bahn ticketing systems, like these remote places, these little huts where you can go in and actually talk to a human being and to book a ticket, but they're not really being used actually, right? So this is just done right, probably, right?
Yes.
Anyway, so what this sparks me a lot, actually triggers me a lot. It immediately, I need to think about AGI when I see these embodied robotics or embodied AI at least, right? So like when do you think these robots and the whole AI systems will be so smart that we're really kind of almost or even replacing humans with this? So is this something you see coming, and where would it happen first?
Yeah, well, I wouldn't say they're replacing humans, but they're augmenting, first of all, our capabilities. If you look at the task-based robots like the Atlas, the Unitree H1, and so on, they can carry quite a bit of load. It depends on how you configure those, but like 20 kilograms, something like this, or maybe even 30, it really depends on the robotic systems, but they can carry quite a bit. And so think about, like, let the robot do the hard work and we save our back, it's like not carrying the heavy stuff anymore. And so you could have one on a construction site, like carrying heavy packs of cement or whatever you can imagine, like these really stupid, simple tasks. And this is where I think we will see quite a bit of robotic systems until the end of the decade. Some folks, very prominent figures in that space, are predicting that we will have more humanoid robots by the end of the decade. So by 2030, then we have humans on Earth. I'm very skeptical on that one, but that's what some people predict. But surely what we will see first is we will see them in factories, we will see them in heavy industry and these kind of settings, because obviously the first versions will also be quite costly. But like I said, we live in a skills shortage in the end, right? There's not enough skilled people anymore to do the work. And so the robots come in to help to skill and to scale these things, because we still need to produce goods. We still need to build houses and what have you, right?
Yeah, that is an argument that we had with one of our previous guests already, skill shortage. But only to recap what we've been talking about, we have these task-based robots, we have those interaction-based robots. They all have their domain in which, just following your argument, in which they augment the work humans are doing. Don't you see all of these capabilities are converging?
Yes. What we're seeing is the human capabilities are being augmented in multiple form factors. So we talked about the robots, right? Like the blue, as they call the blue collar workers, right? But in fact, when we look at large language models and the whole revolution, these transformer-based models kicked off, it's more in the white collar worker, the office worker, right? And I can tell you, I use a large language model pretty much every day because I work a lot with text, writing text, doing slides, just to also brainstorm ideas, right? These are perfect because sometimes they hallucinate, they make up stuff which is not real, but use that for advantage, right? Use that for brainstorming, for thinking outside of the box.
That's the creative part, right? Yeah.
The creative works really nice to bounce off some ideas, or to augment these ideas. And I think this is converging at a certain point that we have these language models and these language-based systems. And what I've shown you with these embodied AI, we control the robot. In the end, what we're leveraging there are all language models. We're using language models to classify what the human is saying and then to trigger the right tasks. So at a certain point, we will have human level intelligence. For certain benchmarks, we might already have achieved it. But sometimes it's a little bit, I would say, too optimistic what is being shown with these benchmarks, because in the end, these language models, or some of those, are also trained to be very good with these benchmarks, right? And so let's see when real world tasks happen. A prominent expert in the AI field, Jan LeCun, very, very smart person. He's also the chief research officer at Meta and professor at New York University. Very prominent figure. Anyhow, what he's saying is, if a robotic system cannot put the dishes into the dishwasher, we're not there yet, and that's still a long way to go, right? And you can tell this to a 6-year-old to do this, right? You can tell your 6-year-old, like, bring the dishes into the dishwasher. Well, try to do this with a robot, right?
That depends a lot on the 6-year-old, right?
That depends on the 6-year-old as well.
Most 6-year-olds, okay, want to do that for you. It reminds me a bit of Alona and Devantro, right? And she was talking about these normal tasks like opening a door, opening the fridge, and how hard it is because there are so many different fridge models, right? So you need to train the robot and the AI with like 20 different fridge models at least to make
this is
make them applicable.
I don't know, Rene, if you saw that episode, Luna from Devantro, they're doing elderly care, and they resorted to telepresence just because of that, because autonomous robots are just not good enough to find their way around in a random home.
Yep. Not there yet, but there's pretty much active research in that space, and we're also working at that. The thing is called, if you're interested in that, for anyone that is listening, it's an open world model, and that's these models that can basically just live in a not pre-trained world, but they can find their way around in unknown environments. That is happening also at the moment. So yeah, that's all of these things are coming together slowly. We have the hardware. Also, folks, you gotta look up a company called Torso, a clone. They produce Torso. It's crazy. It's artificial muscles. So it's not motors anymore. It's artificial muscles. So that stuff is coming as well, right? Because the energy density of human muscles is much, much higher than of a motor. And we need this because we need smaller form factors, right? Of course, I can carry with a robot 100 kilograms, but there would be such a huge motor here. It's impractical. So a lot of things are coming together in that space for sure. It's an exciting time, but also, like, we gotta use these responsibly, obviously. And so always important is human in the loop. Human always controls these things. Human always is in control of those. And another offering we also have is a virtual reality teleoperations, where you can put on a VR headset and you're basically inside of the robot with your eyes and can control it remotely.
Amazing.
So long story short, what you're trying to say is robots are not going to replace any of us anytime soon, right?
Yeah, I don't think so. And again, we have a skills shortage. I think they will help us to actually scale.
Okay.
Very cool. And we talked so much about Gen AI in the last couple of episodes, right? We always said, like, it looks like the content that you get out of a let's say, a creation process from a real human being is then the premium content, right? And that's maybe special. Now it looks like when it comes to embodied AI, right? So if you add a robotic human form factor, then in the end, the real human connections, like being able to touch Andreas, here basically becomes the premium content, basically, right? So that's going to be interesting, right? And if you
premium content,
maybe I happen to have an embodied AI co-worker in the future, and then I would really value the real Andreas next to me, right?
Go out and go on a bike tour while somebody else runs the show.
Yeah, well, or that person goes on a bike tour with me, unfortunately, right? And then I would be really happy to have a real human with me. So let's see. Amazing. Yeah, perfect. Thank you so much, Rene. I think we're gonna drop the regulations topic because that sounds so extremely sad, to be honest with you. Or is it worth talking about quickly?
Well, we can talk about it because I think regulation is important. We need certain regulation for that we. Without mentioning names, but certain countries might not fulfill these regulations too much, and use these AI systems for surveillance and making the human kind of transparent too much. And so it's important that we have regulation that prevents these being abused. On the other hand, we need to be careful that it's not overturning that, because otherwise it's always against innovation, right? So we need the right balance. And so I hope the regulation will go into that direction. There will be some adaptations because otherwise, obviously, the world is still moving forward and we got to follow that. And, we still have a long way to go, I think, in terms of having robotic systems that, like I said, fulfill human tasks. And one example I wanted to make is also, you probably heard about the Turing test, right? Where you can do an AI and see if it's fulfilling the Turing test. And we also hear a lot about autonomous driving systems. Obviously, we have some autonomous drivings like Waymo and other companies that actually already have deployed robotaxis, which is pretty impressive. But you know what the real Turing test for robotics is? It's when we have a humanoid robot that goes into a Fiat Cinquecento from 1957 and actually drives that autonomously for you. And you know how I call it? It's the Turing test of robotics.
I think that's perfect for ending this episode, actually, with the Turing test.
So we can conclude this. There is another test that you came up with, and until the robot passes the Turing test, we're on the positive side. We're on the good side.
Thank you so much, Rene. That was amazing to talk to you. I think we've also seen so many cool videos about robots, and whoever's watching this, I guess, will put some more links into the comments, and you'll have lots of stuff to click to. And also watch the old episodes, right, with Kuka and also with Devantro, which have been amazing. Rene, thank you so much for your time. Thanks everybody for watching.
Just to mention that, also stay tuned for the 4th episode on robotics that we used to.
This time we have 4 episodes. Super strong.
Once
See you
again,
all.
Rene, thank you for being here.
Bye bye.
Talk soon.
Thank you.
See ya.
Ciao.
Thank you. Bye bye.